Hi guys, Mr. Havenhand here. I'm going to try and record as many videos as I can of me going through the pack pages that you've been set as your homework, just so that you've got something you can listen to and watch rather than just looking at a set of model solutions, which I know is not always the easiest thing to follow. Okay, quite a tricky page, this page 14. We're being asked to solve tricky questions using given information. So first things first, what they don't want us to do here is just work this out, even though really we should be able to, but there's a quicker way because they've given us a related calculation. Now if you look closely at these calculations, you can see the similarities. 4.7 and 47, they have the same digits. These are the same digits. So we're going to have the same digits as 159.8 in our answer. The decimal point will just be in a different place. So it's important to think about what has changed in the question. Well, from the question, this number has become 47. Now that is 10 times bigger than 4.7. So the answer will become 10 times bigger, as long as the other number doesn't change, which it doesn't. And one way to explain that is that this is an equation. These two sides of the equations are equal. So if I was to times one side by 10, I have to times the other side by 10. Okay, and that would obviously make it 1598. Okay, on the next one, the 4.7 has gone back to being 4.7, but this time it's the 34 which has changed into a 3.4. So that has become 10 times smaller, or the other way to think of it is that it's been divided by 10. So again, if I was to do the whole equation thing again, 4.7 times 34 was what I had originally, and then it got divided by 10. Now it doesn't matter that it's just the 34 that got divided by 10, I could write that as the whole side. So what's going to happen in our answer is that we need to divide that by 10 as well, which would give us 15.9. Okay, the other way to think of it is that the question, the left hand side has become 10 times smaller, so the right hand side must become 10 times smaller. I've also seen it explained using a decimal point. In the left hand side of the question, a decimal point has moved once to the left, so in the answer the decimal point has moved once to the left. And the final one, these are always a bit trickier, these ones are the divisions. For these I'm just going to talk about how multiplication and division are related for a second. So if we use a fact like 4 times 5 equals 20, then we should know that the inverse of that, doing 20 divided by one of those numbers, let's say the 4, would give us the 5. And 20 divided by 5 would give us 4. So multiplication and division are the inverse of each other. So here I'm dividing 159.8 by 47. So it's the same digits that are in the question. Now that implies that 47 can be times by something to get 159.8. Now that looks a bit more like our question. So 47 has become 10 times smaller, 10 times bigger than it was in the question, yet our answer has stayed the same. So that means the other part must become 10 times smaller. This must become 3.4. to account for that change not really having an effect. And you can kind of estimate that just to check it's right. So 47 is close to 50, this is close to 3, 47 times 3 would give us about, 50 times 3 would give us about 150, so you can see we're in the right ballpark. That's the best way to do these questions. I'm not going to go through all of them, just certain questions. You can pause the video and mark what you've got. Okay, on number 2, I'm going to use the other method I just spoke about the decimal points moving, just in case you prefer that method. So if we look at the calculation, this number was originally 324, and then the decimal point, which would be at the end of the number, just not visible at the moment, has now been moved twice to the left to turn this number into 3.24. as well as that happening, so that would cause the decimal point in our answer to move twice to the left, but as well as that happening, the decimal point in the next number has also moved once to the left. So the overall effect on the answer is that because a decimal point has moved 3 times to the left, which we could sort of say is the overall effect here, then it's going to move 3 times to the left in the answer. So if the decimal point moves from where it is now 3 times to the left, it will be there, and the answer will be 15.552. Okay, next one. From the question, the decimal point has moved 3 times to the left in this number, and it has moved twice to the left in this number to turn it into 0.48. So overall it has moved 5 times to the left, so in the answer it will also move 5 times to the left. Now that will be all the way to the end, so it will actually be in front of the 1, and if it's in front of the 1, we're going to need to add a 0 in the units column. Now, the reason I don't really advocate this method too much is that it doesn't really hold when you come to a division question. In this number, the decimal point hasn't moved, but in the 48, it has moved once to the left. Now, you might think that would cause it to move once to the left in this number as our answer, but it would actually move once to the right. And that's because we're dividing by a number which is 10 times smaller than it was, and therefore we'll get a bigger answer. So when it comes to a division question, I'd suggest sticking with turning it into a multiplication by using what you know about inverses. So 4.8 times something is equal to 15552, and it's going to have these digits in it, but it's going to need to be 10 times bigger than that because this number has become 10 times smaller and we've still ended up with the same answer. So the answer is going to be 3,240. Okay, on question 3, no division questions, which is good because they're the harder type. We'll stick with the decimal point method for now. So in this number, 73 has now become 730. The decimal point here, which was behind the 3, has now actually moved once to the right and is now after the 0. So that's once to the right. And in 234 it hasn't moved at all. So in our answer, the decimal point will move once to the right. Now at the moment it's just behind the 2. If it moves once to the right, I'm going to need to add a 0 in the gap as a placeholder 0. Okay, and the next one, 73 is unchanged from the calculation that they gave us, but the 234 has changed to a 2.34, so the decimal point has moved twice to the left, so in the answer the decimal point will move twice to the left, and it will be between the 0 and the 8, so 170.82.